classes and also file exception handling. These two are also very important. We start using this one next week. This is provide the foundation how you can build on top of other packages. I think functions, classes, file handling, those are things that you probably going to encounter when you try to talk about the open source packages. So for classes, function is a building block. Classes are also another type of building blocks. And it's very kind of so similar functionality, but class is more like you create a class. So all the Python objects are kind of objects. Object comes from a class. So class is more like abstraction of something, right? So if you're trying to create a program, for example, try to store some information for students, you can write a function and then you can try to accept the information and then save into a CSV, save into a file something, but it's not the most efficient. So in that case, you might want to create a class, for example, name students. And then in that class, you can have all kind of property, also called attribute. For example, your name, your address, blah, 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 something. And you can also attach something, actions. So for class, you can have methods. For example, you can register for a class. You can drop a class, you can add or remove a class, something like that. So those are things that can attach to a class. So a class is not something specific. It's more like generalization, abstraction of something. For example, you can create a class called person, and that person can have height, weight, hair color, something like that. The person can also walk, okay, run. So those are some commonality between different objects, and then you can create an object based on the class. So if you use, for example, leaf map, gmap, right? Those are based on the class. So for example, gmap.map, right? That map class. And this we're going to talk about more next time. But for today, I'm going to cover the basics, how you define the class. So here, if you look at this code block, this is kind of foundation, like most basic class. And pay attention to here. In order to define a class, you need a keyword called class. For function, what's the keywords to define a function? df, right? df, class is called class. So those are the reserved keywords in Python. But different from the function, class are title case. Pay attention here, dog, right? D is uppercase. For functions, usually all the functions, the convention will be all lowercase. Class is title case. So basically the first characters use uppercase. You can have another one, right? You can also do camel case. I can do dog and then cat. Okay, like if you're trying to define a class that represent dog and cat, you want to do something like this. So don't use lowercase for functions. You use all lowercase or you use lowercase underscore. So those are called snake case. Snake case. This is called camel case. Basically, every first character of the word is uppercase. Okay, and once you define the class, you see here, we run this one just to show you what it looks like. So the class is going to have some kind of methods, but there's a unique one called init. So this one has two underscore, okay, df underscore underscore, and then another two underscores. Also, you're going to notice this one, self. Self means it's the class itself. So basically, what kind of things you have. And this is the function that being executed when you create the class. So this one is the dot class. And then when you create that one, you need to have passing these two parameters. So the name and also the age, right? So this one here is a function. This one here is a function. So it's also called a method of that particular class. But different from like traditional function, it has this keyword called self. Self, that means you're going to attach this one, this class. Otherwise, there's no way you can keep track of what's in there. So any functions, anything within the class here, you need to have this keyword. So right, self, self, self in here. And within the methods, you can do pretty much anything. But this self keyword allows you to access the information for that class. You can assign things to the attribute. You can get attribute. So for example, set and get. Basically, when you're trying to create a baby, right? You can have the gender of the baby. You can have the weight and height or something like that. So you can assign, for example, when the baby is born, you're going to assign the color plus information to it, right? Or even when the university admits you, they're going to store your information. So inside the database, you can create a class just called students, and you can assign the name, the age or the dress, major, something like that. Put that into the database. So the database can store these objects. So a class is an abstraction. An object is the so-called initialization of the class. So those are two different concepts. Python is a so-called object-oriented computer language. Object-oriented means going to treat things as an object, and that object has all kind of methods and have all kind of functions. You can create something. So here, this simple class right now, if you execute, pay attention, it's only executing the definition. It doesn't really execute these things. These things are only executed when you actually create that class. So this is the initialization methods. And so look at this one here, right? Now I create a dot, and then I'm passing these two. So these parameters here come from this one. Okay, pay attention here. The first parameter is called name. The second one is age. So when you create the class, you need to provide it. So you run this one, right? Doc class. Now you can access the information, right? You can access the doc name, also the age. Make sense? So you create the class, make sure that, okay, when you create this one, you need to have a name. You need to have age, right? So for example, when the baby was born in hospital, you need to give a name, right? And the doctor also needs to record the weight of the baby, right? And also the sex of the baby. Similarly here, right? I can create a code baby, and then you need to give a name. Otherwise, you cannot, right? So here, this is the empty, just a class. And if you don't provide anything like dog, and then just parentheses, it's going to throw an error. It's going to tell you, okay, this init missing two require positional arguments, name and age, right? Because when you specify the initialization, you need to provide the name and the age. You don't, that means you cannot create. And if you recall previously, right, when we define a function, you can provide so-called default arguments. Default means you don't have to provide. If you don't provide, I'm going to assume that it has a default value. So here, right, in this case, I can just simply, for example, if you don't provide, I'm going to simply like equal to age equal to 1, for example. Okay. And right now, if I run this one, create this one, you're still going to get an error, but it's going to tell you you're missing one required position argument, right? Because I provided age, by default, it's going to be 1. And so now if I provide, for example, double quotes and Jimmy, dog named Jimmy, it's going to run, and then you see it's done. The reason it's showing up this one is because when you create this in the object, okay? Right now we're creating an object based on the dog class. I can, and then here we can say dog1 equal to something like that. Then you will not show anything, right? If you don't assign to something, it's going to print out, show you what's there in the memory, right? So again, show you here. If I run this one, I'm going to show you this one. You don't know what it is. So this one is actually the address in the memory. Okay, this is hex code, 16 hex code, so it's hard to interpret. Usually, when you create something, you want to save to memory. Otherwise, there's no point. So I can say dog1 equal to this. Okay, then this is I'm defining creating an object based on the dog class. So now this one here, if you type this one, right, dog1, again, it doesn't show you anything, but once you have this object, then you can press dot. It's going to show you all the attributes associated with this object, right? So you see here the age, the name, rollover, seat. Right? So if I want to access the age, I just type name.age, enter. Right? I can access the name. Make sense? So this is how you create a class. And also you initialize. So this is called class initialization, creating object. And the most important one that you need to have is to have this one. So if you also make sure you have this self keywords, otherwise it's not going to work because you need to access yourself. Right? When you assign something, you need to assign the object itself. The self is basically that object. Without that, it won't work. So most likely, for example, I can create another one here called class. Okay, student, then parentheses. You will see there, right? It's the same thing. It's going to show you, okay, you need to do this. And then I can also have name, age, and then major, for example, right? And from there, you need to have another colon. Boom, done, right? And also def. So only the initialization, you need underscore, underscore. So there's a special one. After that, you can have any major. Okay, it's up to you what you want to do. So I can also, for example, now I can say enroll, okay, enroll, and I can have self, a class, okay, course, course, self 3. Make sense? So I have a students class. You need to provide a name and a major, and that students can enroll in a certain class. For example, you are geography major students. Now you're taking 510, example, right? So how I'm going to do it in here? So I can create this new class, then I can create a student. So this is basically the abstraction. I can create a student name oh Joe, okay, equal to, now it's a student, okay, and name the age major. I'm going to major in GS. Enter. So now this student become the object, right? And I can access the student like information. So go dot major. And you can create another one. I can create another one. Say Donald, okay, equal to student like CS. And I don't need to repeat the information to create a class because we already have the abstraction. Now you can all the information. This. And you can also like Donald, oops, yeah. So enroll, right? And you can provide class, enroll in a Python class. But this one right now is not, oops, it's just the course, not the save the course. Save the course means it must already exist. In this case, you are actually just accessing the information in here. Right. So then now I can run this one. Doesn't show you anything. It's not a mess. So this allows you to create a class, do the initialization, and after that you can have all kind of methods. This is essentially how you can build on top of other objects because right now you're creating a class from scratch, but you can actually have a class to inherit another class. And we'll talk about more next time. But for now, just say, okay, you're going to build things from scratch. Create a class, and then you can have all kind of information, and you can change things. You can access the attribute. You can also, for example, right, have a dot class, have a name, age. You can seek, you can roll over, you can do all kind of stuff. Within the function, you can print out the message, or you can do something else. So it's up to you what you want to do. And so here you can create multiple instances, right? So that one, basically, you can think about the class is a template of creating things. Object, when you define, is basically initialized, right? Kind of like when you're trying to produce a lot of robots. What's that famous TV show like Westworld or something? Let's see if you, yeah, Westworld. You see the robot producing like something like that. It's the robot, the model, how you going to build the robots, and then we can create a different robots like based on that model. Similar, like you're trying to you employee at Tesla, trying to produce different cars. But you need to have the model first, right? How the cars function and then different components. That things is a class. But inside the class, you can have smaller classes. But eventually, it's just a template, basically a blueprint, how you're going to create stuff. And then you can start building things, create different objects. Once you have the object, you can do all kinds of stuff. And instance, right? For example, a car, you can have a maker, model, year, something like that. And then from there, you can get the description. For example, you can have this function, and then you can print out all kind of different type of information, right? So I create a car, give a name, and then different model, the year, and then I can call this function, call describe name or something. It's going to show you all the information, right? 2014 Audi A4, something like that. So pay attention to every class need to have this function, this methods. Otherwise, it's not a class. It's incomplete because you're not creating. So this one is executed when it's created. I can show you here. Like for example, you really don't know how it actually works. I can start doing a debugging, right? So I press a breakpoint here, and or maybe I press a breakpoint here, and you can see how the source code is being executed step by step. So now I'm going to debug this code cell, right? It's going to stop here. Then we can step through to see how it's being executed. So I'm going to stop in the class definition here. And if I run this one, where do you think it's going to go? Where is it going to go? Oops. Yeah, you go to the next one here. And do you think it's going to execute all this? No. So there's just a template. So if you have something in error in here, it will not detect. So this is kind of just like a function definition. Similar to function, it only executes the function definition. Inside, it doesn't execute until it's being called, right? So right now, you see, we have the second one. Run through that, and then it's done. It's going to come out. So only execute the function definition. Now, we are really creating these objects based on the car class. So pay attention to this one. Now I'm executing this, creating a car, providing information. So if I run this one again, where do you think it's going to go? All right, pay attention. Run. Okay. Directly go to inside this initialization. So now we are creating a class. Now it's really executing the content within the initialization. So here on the left side, if you pay attention to this code block in here, we have the year equal to 2019, the Audi, blah, blah, blah. And we are creating a variable. Right now, this variable doesn't exist yet. So if you look at this here, there's nothing. But there's a self. And so we're creating the, assign the maker, the model, the year, and then pay attention, it's going to come out of the class. So pay attention. Okay. So it's coming out. Basically, right now we are creating this object. And if I go to the next one, so you should have this stock object right now, right? So this object has different attributes in here, age, name, and what else? Oh, no, this one. It's my new car is here, right? So now I have this object, and the next time, pay attention, right? So I'm going to print this class, print out the information, see where it's going to go. So I run this one, see, it's directly going to come in here, because earlier we already execute when you create a class, it already executes the function, the class definition methods. Now it doesn't have to execute again. You go directly inside and run it, run this one, return the title, and then you print out the title. Make sense? So all the functions, all the class are being defined, execute only once at the definition, the methods, that's it. It will not detect the error. So if you have any errors in here, you will not know until you're trying to create a class. Make sense? So let me clear this out. And this is how you define a class. Yes? No, you can just have one. So for example here, I can comment this one out. It doesn't matter. So minimum, you need to have this something like this. One class. But so of course you cannot call it if the method doesn't work. But this should work just fine. Right? Okay. But you need to have a minimum of one method, basically initialization. After that, it's up to you what information you want to allow the class to do. And after that, you can have the default parameters. Right now, it's just you see here, right? We have three attributes, and these are three being assigned. We also have a another one. You don't need to assign. It's going to be actually create by default an attribute, but it's not exposed. You don't need to set it when you create it. And this one, for example, if you create a car, the odometer, when it's initialized, it's going to be 0, right? The car doesn't have any mileage. But after you write some mileage, it's going to increase. So here, right now, if you run this class, so pay attention here, right? So this is a car class. You have this information that you can set. This one you have no control. So this one is based on how many miles that the car has driven. And so you're going to say, okay, blah, blah, this car, and it's going to show you get descriptive name and also read odometer, right? So this one is, when this initialize, it's going to have 0 miles. But you can access this one, you can modify the attribute, right? So you can say, okay, right now it has 23 miles, and you can read again. It's going to show you, okay, it has 23 miles. But this is usually not recommended. You attribute, if you don't want other user to modify, you don't want to expose this one. Right now, it's accessible because when you create a new class, for example, here my new car, and then dot, and you can see here odometer reading. And you can equal, for example, I can say 30, and now my new car dot read odometer is going to show you this. So you can access the attribute, you can modify the attribute. So anything within here is a public attributes that user can access. If you want to have some hidden one, usually you have an underscore. So this is more like hidden. It's not going to show up automatically. So if right now, if you have this one underscore, that means you want to have this attribute, but you don't want the user to easily access that. So now if I run this one, and I need to move this too. All right, so I create this new one, and I will say my new class dot. Oh, it's still showing up. So VS Code still shows up, but in Jupyter Lab, it will not show up. So this is underscore, anything underscore is more like a hidden attribute. 2 underscores are basically the built-in methods. So these are usually not designed to be exposed. You don't want to use that. You want to use those that without on underscore. So this is how you define the class. You can modify the attribute. You can modify the methods. It can get quite complicated. But again, make sure that whenever you define something, you need to have a minimum, have a self in there so that you can access the information of itself. So the self means it is when you create the object, you want to access the information on that object. And you can update, you can read, you can do all kind of stuff. So the kind of the workflow is pretty much similar. This is how a class is being created, and you can also inherit a new class. So I'm going to skip and go to this one here. Is the same thing. So update the class and show you what you can. Right. So for example, this is the car, and so the car should have all the information that you want to do, but I can also build on top of the car class. So here, for example, just let me show you here. Right. Again, now we have a car. This is a, for example, Subaru. But you can have another class. So this is how you inherit build on top of another class. So I'm going to define a class, and this time I'm going to say I'm going to create a Tesla class. And then you see how smart it is. Parentheses class. So now that means I'm going to build on top of that class. So this is called inheritance. Inheritance means I'm going to inherit based on another class. And so right now, I don't really have anything else. Just initialization, blah, 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 something like that. The nice thing about this, you don't need to reinvent the wheel, because earlier in this car class, it has all this initialization and the descriptive read odometer update and then increase blah blah. So right now in this class, I don't have those methods, but because I inherit from you, this is more like family. You inherit things from your parents. So your parents have something, you're going to continue to inherit. So this is class inheritance. Is also very common in Python programming. Object-oriented means you don't want to build things from scratch. You inherit. So right now, for example, I can say, okay, number 1 equal to, right? I'm going to create a Tesla. And then I'm going to pass in the name, Tesla Model S, and then 2020, right? So if you press car 1 dot, and look at this. So all those methods that we use from the car class now is accessible. Although I don't define it in the Tesla class, but I can access this. Okay? So this here is important. So if you want to inherit from something, you put the class within the parentheses. For the car class here, this one is start from scratch. There's no inheritance. So of course I can have another one here. I can, if you want, parentheses, and then you can put in another class. For example, from a car, I can have like model or skeleton or whatever. You can do it if you want to inherit. Okay, this is how you do the inheritance. We will talk about more in the next lecture how you can inherit. So for example, you can inherit based on leaf map. So I can create another class called leaf map, another map class, right? So let me just quickly show you here. Right. And then you're going to import leaf map, for example. I'm not sure if I have this class. Oh. This long. So and then leaf map dot map, right? So if you see here, leaf map has a map class, and the map class with a new map, and then new map. This is the map class inherit, for example, from IPyLeaflet. So if you want to build on top of other packages, I can create a new class and I can inherit from the leaf map class. And this is how we build on top of other. For example, here, okay, by default, for example, this is the OpenStreetMap. And when the user create a map, you want to add, for example, maybe the open topo map, for example. So this is like if you don't create a new class, you will need to do something like this. You want to add base map. Okay, I don't know how it now knows what I'm talking about. Open topo map. See, you need to write these lines. But if I'm going to build on top of this one, you're doing something related to topography. I want to create a map class. Then when user create a map, I want them to add this one. Make sense? So easily I can come here, just to show you like how do you build on top. I can say class map. Okay, so I'm going to create a map class, and that map class inherits from leaf map.map. See here? And so I'm going to create this one, and then if you inherit, there's going to be a super blah 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 dot init. Okay, so once you have this, then after that I can just run this one. So pay attention here, right? Pretty simple, right? I inherit from the leaf map, and this is how I'm going to initialize. Also, when you initialize, I'm going to call the leaf map.map, and it's going to pass in to become a self. Basically, your parents. You need to tell your parents, I want to create something based on yourself, and then you return that one to me. Now I have a handle to this object, then I can do anything. So this one here basically is self.add base map, and then add the topo map. So now, if you look at this one here, m1 equal to, so I have created a map class. I inherited from leaf map. Now I create a new map. Okay, map 1. So take a look. See? So now instead of previously, you need to add the base map, you need to do all kind of stuff. Now, I just one line of code, you create a map, and then you build on top of others. So in that way, it saves you a lot of time. So in there, you can do all kind of things, not just like, for example, I can add another one, okay? I can also say cell map dot, oops. Or I can, if you feel that, okay, these things are too crowded, there are too many stuff on the map, I just want an empty one, I can do that as well. I can just come here and save dot clear. There's a function called clear controls. Okay, so take a look. So now I create a new class view on top of IPy leaf map, and then take a look at this one. See, I just create an empty map without anything, and it's just one line of code. There's nothing else. We practice a lot more starting from next week. For now, just to give you some flavor. So this is essentially how you want to build things from others, either using class or using a function. And you can put a lot of things within what you want to do, rather than you have to write many lines of code, right? So if you're trying to develop a program that allow the user to read some data and then do some data processing and then display it, if you're using other open source, you might need to write many lines, but you can, in your package, you can just do like apply the class, and then you can point the class to some parameters and then just run all this. Anyway, so this is what is coming in the next lecture. But right now we're just using a notebook. We haven't really do anything yet, but it's going to be a lot more down the road. And so that's about the class. So next, let's go to files handling and also exception handling. So this one is also super important because if you're doing geospatial, you're going to encounter files handling all the time. Either it's a CSV, Excel file, or it's going to be straight file, GeoJSON, or GeoPackage, or GeoDatabase. It's going to be all kind of things, and you need to know how actually to deal with file. So this lecture here only deals TXT file. It's a pretty simple one. But later on, when you build the package, I'm going to teach you how to handle other vector data, other geospatial data, raster data, vector data. For now, let's just deal with a simple one. So in order to run this one, you need to have some sample data set. So it's under here. I have some data under the data folder. And so when you are handling the files in Python, there's a file function called open. And then you pass in the file path. So pay attention to this one here. I would like to let you know, later on when you develop your program, make sure that you don't have any absolute file paths, okay? Absolute and relative are the two concepts that you definitely need to understand. Absolute file paths means C colon slash blah blah. There's something like absolute. Relative means it's relative to the file currently you are running. So if I'm asking you here, this file path, is this a relative file path or is it a absolute file path? Relative, right? If this is absolute, it's going to be something like this. So let me open this open finding folder. Oh, it's not going up. Absolute path will be like this. I'm going to C drive or go to my this folder and then docs, right? Within there, Python, then data. So your absolute file path will be this one. Okay. So pay attention, right? Of course, I can come here, I can copy, and then I can paste my code into here. And also, you need to pay attention to Python. When you're dealing with file paths, depends on whether it's if you're dealing with file paths in Windows, it's using the backslash. On Mac and Linux, it's using forward slash. Python is also using forward slash. So if you're trying to write this one, I'm not sure if it works or not. It may work right now. Python is a bit more intelligent, but usually you don't want to copy the file path and then put it to here directly. So it's going to use the backslash. You see, it's not working. It says Unicode blah blah, and decode the bytes in position blah blah. So this file path is the correct one for Windows. But if you're using it in Python, you need to put an R at the beginning. So pay attention here. Put an R at this file path, right? R, and then double quotes, and then you put in a file path. So right now, this is an absolute file path. If I run this one, you should see I'm able to run. So the R, it means raw, RAW. That means you want to treat this string as it is. Otherwise, the escape sign here, backslash, has spatial meaning in Python. Remember? So previously I showed you, like I can just print and then parentheses, double quotes, backslash n, backslash t, and then hello, right? So the backslash has some spatial meanings in Python, and that's why here in this file path, if you have the backslash, it's going to be very weird. So if you want to treat it as a file path, make sure you put an R at the beginning, and this is the easiest one. Or you can have something like this. It's going to take some time to change. You need to have double slash. So if you have two double slash, it means you're going to treat that one as one back. So the first one backslash is a spatial character. The second backslash is the real backslash going to be used. But you need to put all the backslash. You need backslash here, backslash. So you need to change all of them. So usually it's not very convenient. And the easiest way would be just put an R at the beginning. So this is for Windows only. For Mac and Linux, you can just copy the file path. You don't need to change. Right? You're using Mac. This is good for you. So you don't need to change it. But if you develop Python, make sure that you don't do it this way. It's really bad. You notice in here, if you copy this code block to your computer, it will never work because the file path is different from my computer to your computer. So you should not, anything that you put on the internet, you have package in notebook, don't have any personal information, file path or anything that other people doesn't use. So this is why it's better to use the relative path. That means, okay, I'm running this notebook. As long as the notebook is under the same directory of this one as a data folder, then you can run it. So now if I remove this one, and then I have to open, oops. And this is super important because as beginners, you're going to run into this issue all the time. Oh, I'm pushing this notebook to GitHub. Why it doesn't run? Because it cannot find the file. The file is on a local computer. It's not on the GitHub. So you need to make sure that how do you make the file accessible both locally, but also when you on GitHub, it's also available. For now, this is just a simple file because it's the same, right? It's also on my GitHub, so it works just fine. So this is a relative path, and also if you do it in Python, it should be pretty intelligent. So I can have double quotes, and then if you just type data, usually it should it's not coming up, but if you press Control Space, it will pop up and let you show the list. So I'm going to do it again here, right? When you type in the file path, the directory. So the first one here, I know is under the data, and then /. Sometimes if it is not showing up, press Control Space, and then it's going to show you the list of the files, so basically the one from here, right? And then you can select something like this. On it. So the open function allows you to open any txt file and read the content. So when you're doing the read, it's going to read the entire content. So this is how you read the file. This is one way. The second way is to read this line. Read all the list. This is a simple, just an entire string. Although it looks like 3 lines, this is just 1 line. It's just all the contents is a single string, right? Once you have the content, then you can access the content, right? So it's just this is just a content. Then you can treat it as a list. For example, I'm going to read the first 5, right? Or the first maybe 50. You see? So when it's printed out, it looks like this, but this content actually is just a single string with some special characters in there. \n. This is when it's being printed out. It looks like that. If you're only accessing the content, it doesn't show you. But if I say print, it will show you differently. So if you don't call the print function, you can see behind how it's being store, how the information is being stored. So this is one way you can read the line, but you can also read all the lines together. So let me show you the other way. This is one way. This is another way. This is a recommended way. Okay, and usually you don't need to say like file object. Usually I would do it like this. If open the file as if, and then if the read, and something like this. So again, this variable. So what we are doing here is basically tells Python, okay, open this file is if more like is a handle, okay. Basically, okay, open that file, and then I want to access the content of that file. So this one is basically just a variable. It doesn't matter what you use. This is basically just the handler. And so what you want to do is like this, okay. It's going to be read lines. This is a better way, because usually when you read the file, you want to have access to the content. So, and then I can say lines, and then clean out the lines, okay. So the reason why we want to do this, because you can read, depends on how many lines in the file, you can read all the lines as a list. So all the stuff are going to be in the list, and then you can just do the looping, right? Then I can say for line in lines, okay, oops, lines, and you can print out the line strip. Right. So it's especially if you open a CSV file, your CSV file has a lot of stuff, and you want to loop through them. This is a better way. Okay, and this is using the built-in Python open. It's good for doing like text data, but if you're reading, most likely more common one would be CSV or Excel file. Next, let me quickly show you how you read the CSV, just one line code. So for CSV, of course you can use CSV is plain text, right? So it's the same as TXT. You can use the open function to open, but usually you want to use the pandas. It's much easier. So let me show you. Okay, import pandas as PD, basically a shortcut. Okay, and then you can use this one to read any files, either locally or on the internet. So I can say define a variable called data frame equals to PD dot read something. This probably doesn't. Oh, there's a, for example, I have a CSV file here under my data directory, so I can do it like this. Under the data, and so tn control space place name .csv hit tab, and so look at this one, right? PD. So the panda is going to read this CSV and see what happened. Control slash df. So now I'm reading this CSV, and it's going to present it as a data frame, basically a spreadsheet. You open this one directly, it looks like this. So it's just a CSV with a bunch of content. And the nice thing about this, now you can access the column. So if I go back to this CSV file here, open this one, you can open using Excel or any text editor. So the CSV is just a plain text. Don't convert. So it's just a table. So most likely, if you're doing something geospatial, you're going to handle some data like this, and it's a table. But for if you want to, for example, look at this. This is all the counties, all the cities in Tennessee, right? And you want to access, for example, the population or the elevation, or anything you like, right? Longitude, latitude, the elevation, average, for example. You're trying to figure out the average elevation of all the cities in Tennessee. This one has how many? Like a couple thousand here, 7,000, right? So what you want to do, right? What I'm going to access is this specific column, this one here, elevation meters, right? So if you're trying to calculate average, of course you can open the Excel and then you just like, okay, write a function and then try to do that. But if you know Python, you can do that for, doesn't matter how many cities, it doesn't matter how many states you have. You can just do a looping, right? You can loop all through. For example, this is a Tennessee. I can give you 50 states, 50 files. You're not going to open one by one and then trying to do the calculation manually. If you know Python, it's pretty easy. Couple lines of code. So So let me come back to here just to show you, right? So right now I believe this one is a data frame. I want to access this elevation meter, this column here, and it's pretty easy. It's going to be EF, and then going here, you can say ELEV, you see, elevation meter, run it, I'll show you here. Now I have access to that specific column, and then I can just say values, is you access to all the values, and then you can turn it to a list. Okay. And from there, you can calculate the sum, you can calculate the minimum, you can calculate anything that you can do, right? So I can just come beginning. For example, I can figure out the maximum elevation. Just press max. You can get the number, you can minimum, maximum, you can do all kind of stuff. So Pandas is a great package for reading tabular data, CSV, Excel file, something like that. And GeoPandas is the one that we're going to use to read vector data. For example, GeoJSON, Swapfile, Geo package. We talk about that in next lecture. But for now, at least you know how to read a CSV. Read a TXT file. So TXT file, you can use the open. CSV file, you can also use the open. But like I said, you usually want to use build on top of these packages because you have a lot more flexibility. It's much easier to read that those. And besides reading, for example, from local file paths, nice thing is that you can also read files directly from the internet. So here I can show you another example, right? So assume that you find some data from the internet. Now you want to read the data. So the easiest way would be to, maybe you can download the data, but for me, for example, I don't want to download. I just want to, so I have some data, for example, under the data repository. And under here, I have put some files, right? Under this one and under the files, you have a bunch of this hydrological unit. I have all this CSV file in here. So for me, I just need to hover my mouse and then find this file. So if I click on the file, it should pop up, ask you to download. That's nice. That means it's a direct link. So for me, I can just simply come here, right click, and then copy link address. Okay. And then I can come back to my source code. I can paste it here. Paste. So HTTP blah 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 blah, and take a look. Run it. It should work just fine. And now I have this column. You see correctly. So Panda allows you to read any file from the internet. Okay. I think we're out of time. So the last one is about the exception handling. I think we already discussed that in some of the previous examples. So try except blocks. So you can follow the examples. And so starting next week, we're going to do some geospatial and also start building your package. And when we are doing that, we also use this try except just to show you how to utilize that. But we will not cover in here in today's lecture. But you can go through that. This is just a pretty simple, basic example here. And the lab assignments, we ask you to use some of those. Hopefully, now you have a good understanding of the basics. And then starting next week, we dive into geospatial. Okay, so that's all for today. I will see you next week.